All right, this second slide show looks like it's about basically factoring, okay, which is, I mean, what we just kind of did on the other problems. But he reviews real quick about factoring, which is breaking the number down into the pieces that make them up and their inverse, okay, that's including the negatives. Most of the time we kind of forget those, but we're going to need them sometimes. So for like this product, okay, the product of these two things, these are called the factors. We just didn't used to call them that. We just said, hey, multiply these two things together. But when we're going backwards and breaking this section up back into the component factors, that's what we're going to be looking at. Okay, so let's see. We want to get them to the prime factors, which are the pieces that we can't break down anymore. Okay, and then we can be called it factored completely once we've done that, when it's only prime factors left over. He gives you some examples, but then he asks you about these. Why is 3x minus 9 not a prime polynomial? Because I can take a 3 out of there, and I'm left with x minus 3. These would be the two prime factors for this problem. X squared minus 1 is a perfect square. I'm sorry, a difference of perfect squares. So that means it's made up of x plus 1 times x minus 1. And so this would be the prime factorization of that polynomial. It's not factored yet. So, but that, I think we've, even when we did algebra those years ago, we did a little bit of this kind of stuff. So hopefully you remember some of it, or it comes back to you. All right, identifying common monomial factors. All right, 2x minus 8. What does both of these have in common? Well, 2 goes into both 2x and minus 8. And so I'd pull that out, and I'd be left with 2 times x minus 4. Okay, x squared minus 3x. What do they have in common? An x. You pull that out, and you're left with x times x minus 3. And then a squared b minus 5ab. What do they have in common? They both have at least one a and a b. And so when you reduce that out, when you factor that out, you're left with a minus 5. Okay, so that part hopefully was pretty simple. Let's go into the next one. Okay, factor the difference of perfect two squares and the sum of. All right, so all this is like the stuff that even I can't, remember off the top of my head. This, it would be a nice thing to study and practice. Depends on if he even lets you use notes during a test or anything like that. But right here, the difference of perfect squares, your x squared minus whatever your a squared is going to bring it down into the difference of those. You got one positive, one negative, because it cancels out the middle part. Perfect squares, you still have the middle part, and that's why you have x plus that number squared if it's positive, or x minus that number squared if the second section is negative. If you can remember, we used to break these things down into A, B, and C, where A would be a 1, B would be right here, the 2 and the times A, and then C would be this section over here. All right, the sum of two cubes. All right, this is for sure the things that I'd have trouble remembering. If you can at least be able to tell if numbers are cubes or not, you can break it down into x plus a times x squared minus ax plus a squared. Or if it's a difference of perfect cubes, then you need to say x minus a times x squared plus ax plus a squared. I did this one on the previous slideshow, and I got this from a website because I couldn't remember this off the top of my head. I don't do this stuff quite enough to do that, so I don't blame anybody else for using notes to help them. All right, so let's go to the next section. Factor these completely. All right, well, this was a difference of perfect squares. Okay, you're going to be, the square root of the first one is x, the square root of the second one is 4, and so there's your difference of perfect squares, x minus 4 times x plus 4. All right, over here, number 2, it's very similar. It's a difference of perfect squares. 9 is a perfect square of 3, 4 is a perfect square of 2, a is a perfect square, b is a perfect square, so I'm going to say 3a minus 2b times 3a plus 2b. All right, right here it would be a difference of perfect cubes. So I'd go to this formula up here, okay, and use that one. 2a is going to be your basically your x, okay? That's the cube of this part. Your a in this situation was the cube root of 27, which is 3. And so wherever you see an x, you would use 2a. Wherever you see a, you would use 3. And so it'd be 2a minus 3 times 2a squared, which is 4a squared, plus 2a times 3, which would be 6a, plus 3 squared, which is 9. So I'll work that out in just a second. Let's see. What did we say? 8. All right. So 8a cubed minus 27. All right. The cube root of 8 is 2. The cube root of a cubed is a. So 2a minus 3 times, all right, so 2a squared, 2a squared, 2a times 2a is 4a squared, plus, all right, a times x. This is our a, this is our x. Oh, this is our a, and this is our x. Sorry, got that. It's flipping back and forth and doing class. All right. 3 times 2a is 6a. And then a squared, which we said was 3, was plus 9. All right, so it should look something like this for factoring this problem right there. A cubed plus 8. Those are both perfect cubes of a and 2. And so I would just do this right here, replacing the x's with a's and the a's with 2's. I know they have used a's for both positions. That's kind of confusing, but so it would read a plus 2 times a squared minus 2a plus 4. And then a to the 4th power minus 16. All right, so a to the 4th power is actually a perfect square of a squared. Okay, 16 is a perfect square of 4. So it'd be a squared minus 4. Oops, that's parentheses. Times, I hate this thing, but I'm trying. A squared plus 4. And that would work out to give us a squared minus 16. So it's using this, okay? Use these to help you. All right, perfect squares, x squared plus 6x plus 9. Well, that's going to be x plus 3 times x plus 3. The square root of x is x. The square root of 9 is 3. Okay, 25x squared plus 30x plus 9. Well, that'd be 5x. Is that square? Plus 3. Just got square. Remember, if I multiply these times each other, 5x times 5x is 25x squared. 5x times 3 is 15x. 3 times 5x is 15x. 3 times 3 is 9. And so it all adds up. But again, they may have the perfect square formula right here to help you. All right, second degree polynomials. Let's see. So we have our x squared plus bx plus c is broken down into these parts. So let's see if we can use this formula to help us. X squared plus 7x plus 10. All right, our a is 1. Okay, we don't really use that very much, but we have the b and c. So the b is going to be broken down into a plus b, and the c is going to be broken down into a times b. So our c is 10, okay? And our b is 7. And so what numbers multiply together to get 10, add together to get 7? Well, that's 2 and 5. Okay? Multiply together to get C, add together to get B. Well, 2 times 5. So that's what I'm going to break it down to. X plus 2 times X plus 5. If you can remember, I believe we did this all those years ago. We did the X square thing where we put the 10 up here and the 5 up down here, and we said, you know, what numbers multiply together to get this and add together to get that. Sorry, not 5, the 7 down here. See, I'm making so many mistakes. I'm nervous trying to do this again. If that looks a little bit familiar, that's kind of what we did all those years ago. So hold on just a second. And let's see. So we did that one. This one, we need to find what numbers multiply to give us 8, but add together to give us -6. All right, what numbers multiply together to get 8, but add together to get -6? Well, I think that's -2 and -4. So that's probably what I would break it down into, is x minus 2 and x minus 4. X times x is x squared. X is -4x. This will be -2x, so that makes -6x. And -2 times -4 would be +8. So that should work out for that one. And then y is x squared plus 9 prime. Well, it's because this is perfect squares, but it's not a difference of perfect squares. Okay, there's no way to break this down into two other ones. Let's see if we can go back up. Okay, it's not a difference of perfect squares. It's just two perfect squares being added together. Okay, so there's not a way to break that part down. There's no common factor between both of these, x squared and 9. There's not something that you can pull out. So how would you show it? I'm not actually quite sure how they would want you to do that, other than saying that there's no common factor. So let's see, factor in step second degree polynomials. Let's see, well, as long as a is not equal to 1, a, b, c, and have no common factors. So let's multiply together the first number and the last number. Okay, I was talking about that a while ago. I just mentioned it briefly that we labeled the coefficients a, b, and then the common constant c. So we multiply together the first coefficient and the last number. We need to find a pair of integers who multiply together to get that and add together to get the middle number. Okay, so it's very similar to what we were doing before. And then we write it out this way. And then we group them together and factor those. So I would, hold on, oh, cancel. I would group them together like this. I'd put parentheses around this part, pull out the common factor, and put a parentheses around this part, and see if I can pull out a common factor. And the factors that I pulled out would be the new part that I would put right there, and what I'm left with should fit in a parentheses here. It's easier to look at when I actually have numbers instead of just trying to say it out now. So let's see for the next one. Oh, this, hold on. I'll turn that part off. Cancel, cancel. So let's see. All right, 2x plus 5x plus 3. So we need to see 2 times 3 is 6. What multiplies together to get 6, but adds together to get 5? And that'd be 1 and 6. Sorry, 2 and 3. Sorry, 2 and 3. Multiply together to get 6. Add to get 5. And so I break it down into the middle section right there. 2x squared plus 2x plus 3x plus 3. You factor out on this, when we group it, okay, I can factor out a 2x from both of these. That's here. On this one, I can factor out a 3, okay, that's here. And I'm left with x plus 1 on both of them. And so we just do the reverse distributive property sort of thing, and we pull out our 2x plus 3. There it goes. And we're left with our common factor of x plus 1 there. Okay, same on here. 2x squared minus x minus 6. 2 times 6 is 12. What multiplies together to get negative 12, but adds together to get negative 1? And that'd probably be negative 4 and positive 3 is what I would say. And so I would say that is 2x squared minus 4x plus 3x minus 6. All right, we do our grouping. 2x can pull out of these first two, and I'm left with x minus 2. 3 can come out of these second two, and I'm left with x minus 2. And then you put them together, and you got 2x plus 3 times x minus 2. As I said, I'm sorry for this messy computer doing this. Just try and listen and watch what I'm doing the best we can. All right, so next, factor by grouping. I'll be back and do this. So factoring by groupings, well, some of these are already grouped. Like this one has already been factored out in x. This one, the 3 has already been factored out. So if we just want to put it together, it's going to be x. Well, hold on, let's get this right. X plus 3 and 1. And they're both being multiplied times x squared plus 2. So that's like sort of like the reverse distributive property. You're just factoring them out. Okay. X squared plus 2 is like a prime factor. You can't really break it down. There's nothing that goes into both of those. And they're not perfect squares. This one, it's already spread out so that we can easily group them. Okay. We'll just group this side and this side. So this first section, we can pull out an x squared from both of them. And that'll leave me with x minus 4. So the x squared comes out on that one. Over here on this side, we can pull a 2 out. And so that leaves us with x minus 4 over here. And so we would just need to put those two together. So x squared plus 2 in one parentheses, x minus 4 in a separate parentheses. X squared plus, it's hard, as I said, plus 2, x minus 4 over here. So that would be factoring that group. All right, let's see. What is number 3 saying? Okay. Find the common factor first. Well, let's see. Right now I see an x minus 1. There's at least 2 x minus 1s on each one. Even though this one's got 3, that means it's got at least 2 inside of it, and I'll be left with 1. And there's at least 3 x plus 2s on both of them. So what would I pull out? I would pull out x minus 1 squared, and then x plus 2 cubed. And what would I be left with is 3 times an x plus 2, x plus 2 that was left over when I pulled out the 3 of the x plus 2's. Okay. Plus 4. And what did I have left over here? 1 x minus 1. So I'll keep that right here. 4 times x minus 1. I only had 1 of those left over when I factored out these 2 out of both sections. So x minus 1 squared times x plus 2 to the cubed times 3 times x plus 2 plus 4 times x minus 1. We can't really combine those, so I kind of need to keep this as a separate section. That's why I have like double parentheses in here. Okay, so it's like this whole section, but I was able to factor out these 2 things. And then the last one, x cubed minus 8, is just, as it says, use the formula or the trick. The perfect cubed is a difference of perfect cube. So it's going to be right there, difference of perfect cubes. You just fill it in and you should be able to do that one. It's like, I think we've already done it previously, but just use the formula to break that one down. Remember, an x is going to be your x in this situation. The cube root of 8, which is 2, is going to be your a. Okay, so you're going to have x squared plus 2x plus 2 squared, which is 4. You just need to break that one down using that formula. All right, so then it gives you this factoring summary. All right, checking for special products, sum of cubes, difference of 2 cubes. Okay, common monomials is always do that first. That's the easiest part. That's why we do it first. Check for perfect squares, and then it's going to be either perfect squares or a subtraction of perfect squares. And then we factor using the grouping methods that we talked about. All right, completing the square. Okay. Now see, I actually do remember this because I think we had like a little video that had a little song with it that played and that some of the kids enjoyed, I thought. Or not really enjoyed, it's probably just made fun of, but whatever. Still, maybe it helps remember for at least a week or two. But completing the square. So when we have these, they don't really factor according to the rules that we've already had. So what we need to do is change them, manipulate them to get them to look like something that we have a formula that we can then use on it. Okay, so let's see. So how do we change it? All right, so here it is in this little section. What we need to do is take half. Oh, they didn't give me the formula. I'm going to take a minute to remember this. Half of the b, okay, the second coefficient. So whatever's in front of your x is your first coefficient. Whatever's in front of your, whatever in front of your x squared is your first coefficient. Whatever is in front of your x is your second coefficient. You're going to need to take that, half of that one, and square it and add it to both sides of the equation to keep it equal. All right, this is going to be easier to talk about, to do than actually explain. So let's see. X squared minus 8x. All right. So I need to take half of 8 minus 8, which is 4, square it. So that's going to be 16. And now I can't just add 16 from anywhere. And so I also have to take it away. So it's going to be x squared minus 8x plus 16. As I said, I can't just get plus 16 from nowhere, so I also need to have a minus 16 to make sure I keep it even and balanced. We'll get to that in a second, but for right now, x squared minus 8x plus 16, that at least is a perfect square that polynomial that I can break down into x minus 4 and x plus 4. Okay, so by completing the square, you're trying to get it so that one section you can now break down into using one of the rules that we've talked about. And yes, you are left with a minus 16 on the end to help keep it all balanced and stuff, but there it is. That is the way to break down x squared minus 8x. So let's look at the second one. X squared plus 4x. All right, you take half of this one, which is half of 4, which is 2, square it, which is 4, and now we're going to say x squared plus 4x plus 4. Now I can't just pull a plus 4 out of nowhere, so I need to keep it balanced and even by taking away 4 also. Okay, because 4 minus 4 is 0, so it's really like I'm not doing anything. I just want it to look better, and so that's why we do this. All right, now x squared plus 4x plus 4, that can be broken down because it's a perfect square into x plus 2 times x plus 2. So really x plus 2 squared. But you still got to keep that little minus 4 on the end so that when everything comes back together, it's all balanced and you get back to where you started from. Let's see. Similarly for this one, a squared minus a. Well, the coefficient is 1 right there. And so if you take half of 1, that's 1/2. And then if you square it, that'll be 1/4. So it's going to say a squared minus a plus 1/4 minus 1/4 to keep it balanced. And then this a squared minus a plus 1/4 is just going to be a minus 1/2 squared. Because when you minus this 1/4 on the end, when you re-multiply it out, you'll have two negative 1/2 a's, which will add together to give you a 1a, a negative 1a. And so when you multiply negative 1/2 times negative 1/2, it'll be positive 1/4. So that's completing the square. Okay, you can do the same thing with this 5. Just divide it by 2. It's a fraction. Square it, add it on at the end, but also don't forget to subtract it. Okay, just to keep it even and balanced, and then you can change it using those rules at perfect squares like that. All right, so yeah, mostly this might be because I didn't have. Oh well. There you go. Hopefully it helped a little bit.